Assalamu alaikum students. I am your teacher Aisha Anwar. We have revised the important concepts from chapter number 1 in our previous lecture. Today we are going to revise the important concepts from chapter number 2, which is about system development life cycle or software development life cycle. We are going to revise the important concepts. First of all, we need to understand what is SDLC. SDLC is basically a set of techniques, models, and methodologies which is used by software engineers to develop or produce the softwares or projects. We refer those softwares as system also. There are a set of these models, methodologies, and terminologies that is available, which is used by the experts to develop the systems. Not only to develop the systems, but also to deploy and maintain the systems. We have studied about the phases of SDLC. In our lectures, we have discussed that there are about 10 phases of SDLC. These phases start from defining, then planning, feasibility study, analysis, requirement engineering, design, coding, testing or verification, deployment or implementation, and in the end, maintenance and support. This is the diagram which represents all the phases of SDLC. You must have noticed the flow from the first phase, that is defining. After performing the and working on this phase, then we will come towards the planning phase. After planning, we will move towards the feasibility. After conducting the feasibility study, we will move towards the analysis, and in the same way till the last phase, maintenance. And from maintenance, if some features are to be added, updated, or maintained, we have to go back towards the defining, so that the new feature that is to be added must be well planned, well defined, so that it can be incorporated into the system, and we deliver the maintenance also error free. Let's go through these phases one by one. Defining phase. As its name shows, in this phase, we are going to define the problem. We define the problem or the system to be developed. And we try to define the system very clearly in this phase, so that in later stages, there will be no discrepancies. All the requirements that are to be integrated into the system are documented and approved from the customer. All of this activity is done in the defining phase. Next one is planning phase. After defining, we will move towards the planning phase. The basic aim of the project is determined and the requirements to be produced, the products are considered. We make an estimate of resources which are to be used during the development of the product. All the information is analyzed to see if there is an alternate solution is available or not. If there is no alternate solution is available, then the information is assembled into a project plan and presented to management for approval. If some alternate solutions are available, then we go through them all the solutions one by one, and we find out the best solution that is available. After conducting the planning, we have to conduct the feasibility study. It is basically used to assess the strengths and weaknesses of a proposed system and present directions of activities which will improve our project and achieve the desired results. Feasibility study is basically the analysis and evaluation of the proposed system to determine whether it is feasible or not. We conduct the feasibility on these 5 major factors. We check the project whether it is technically feasible or not, economically feasible, operational feasibility is also checked. Then we check whether it is legally feasible or not. And in the last, the schedule feasibility. We check the schedule feasibility so that we give the practical deadline to the customer that after 3 months or 6 months or an year, we will deliver your required software. And this schedule should be feasible. It should not happen that if in planning we say that your project will be completed within 3 months and basically it is a huge project which will take more than 6 months. So we should give an estimate of a time which is feasible. After feasibility study, the analysis phase is conducted. During the analysis phase, the project team determines the end user requirements. In this phase, the in charge of the project team must decide whether the project should go ahead with the available resources or not. Analysis is also looking at the existing system to see what and how it is doing its job. The project team may ask the different questions during the analysis phase, such as, can the proposed software system be developed with the available resources and within the given budget? Will this system significantly improve the organization? And does the existing system even need to be replaced or not? Once we have got the go ahead signal, then the next phase is performed, which is requirement engineering. It is the process of determining users' expectation for a new or modified system or a software. It is a set of activities used to identify and communicate the purpose of the software system and the framework which it will be used. Requirement engineering consists of the 3 steps. First of all, we gather the requirements, then we validate the requirements, and in the end, we manage the requirements. Requirement gathering is the very first part of any system or software development process. To gather the requirement, different type of activities are performed, different and various meetings are conducted to analyze the requirements and the features. Basically, there are two types of requirements that are determined in this phase. Number one, functional requirements. Number two, non-functional requirements. Functional requirements specify the working of the software or the functionality of the software that are required into a product. And non-functional requirements specify the criteria for checking the functional requirements, or you can say that it is the criteria to check or to judge the operations of a system or a software. In non-functional requirements, we basically give the requirements for checking the operations or checking the functionality of the system. After the requirement gathering, we perform the validation. Validation is concerned with the examining the requirements, whether these requirements are meeting the intentions of the customers or not. Verification and validations are the different processes. In requirement validations, the highlighted or the gathered requirements are reviewed to check the requirements completeness and accuracy. After checking the completeness and accuracy of the requirements, we have to manage the requirements. Requirement management is performed to ensure that the software continues to meet the expectations of the customer and the end users. If there are some requirements we feel that are missing from the very first stage, then we gather the new requirements and process them in order to incorporate into the system. Once the requirements are gathered, we will move towards the design phase. The design phase is also known as the architectural phase of the system, because in this phase we design the basic structure or the basic architecture of the system with the help of some type of charts and algorithms. In design phase, we develop the logical design and the structure of the system. In this phase, first of all, we write down the algorithms, and those algorithms are then translated into the flowcharts. This is an example of an algorithm. It consists of some basic English words and some type of operators and numbers which mention the conditions that are required. Those algorithms are then transformed into the form of diagrams, and those diagrams are known as the flowchart. Flowchart shows the steps of the algorithm in some basic or geometric shapes. Some specific shapes are used to specify the different operations. Here is the list of shapes that are used. Oval shape is used to determine the start and end of the algorithm. Then input and output operation is represented in parallelogram. The rectangle shape is used to indicate the processing. These arrowheads are known as the flow lines, which are used to represent the flow of the system. Diamond shape is used to check the conditions or to represent the decision structure. And the small circle is used to connect the flowcharts. It is known as the connector. It is an example of a flowchart. After reading marks, it is checking for the condition. If marks are greater than 40, then print pass, else print fail. After designing phase, we actually have to develop or code the system. In construction and coding phase, the programmers use some high-level language to write down the code for a program. Coding is the process which is also known as computer programming. Here is an example of a code which is written in C++ language. You can see the percentage is taken from the user. First of all, a message will be displayed on the screen, enter percentage of a student. User will enter the percentage that will be stored in the variable percentage. Here, it is checking for a condition. If percentage is greater than or equal to 40, it will print the message pass on the screen, else it will print the message fail. After coding, testing or verification is to be performed. System is tested before the delivery, and the main purpose of testing is to deliver the error-free or bug-free system to the customers. To perform testing, the software testers write the test cases to check the results of a software against the pre-specified requirements. For example, in this case, the tester will enter the different values to check if the program is giving the right result or not. Test case 1, the tester has entered the value 70 and it is giving the correct result. Test case 2, now the tester will enter some value which is less than 40 so that it will see that it is giving the right message or not. The tester has entered the value 20 and yes, it is given the right result, which is fail. Once the system is tested, now it is ready for the deployment and implementation. And to perform deployment, various techniques are used. These techniques are direct implementation, parallel technique, phase technique, and pilot technique. We have already discussed them. Today we will just go through them with this diagram. As you can see that this is the diagram of direct cutover. The old system is directly replaced at once with the new system. In parallel operation, the old system is running as well as the new system is also running, and then finally the users will shift towards the new system. Then pilot operation, the new system is installed for some small number of users, then other users will also shifted on the new system. Then phased operation, old system is gradually discarded and new system is gradually implemented, and finally the new system is completely implemented. After deployment, the last phase comes, which is about maintenance and support. As maintenance is an ongoing process, whenever there is some error comes or some modification is to be needed or some new phases or new features are to be integrated into the system, all of such activities are performed under maintenance. That's why we have named it as an ongoing process. And for modification and maintenance, we have to go back into the planning phase as we have discussed with the help of a diagram. So with the maintenance, all the tasks and all the phases are completed. So here is your today's task, after which your attendance will be marked. You have to mention the reason why design phase is referred as architectural phase, and you have to mention the importance of algorithm and flow charting. That's all for today. I hope after listening this revision lecture for SDLC, your concepts are much clearer now. It is an important topic from exam point of view. So that's why we have discussed. If still you are having any queries and confusion, please discuss. Thank you.